Water on Mars. While Mars's surface is currently cold and dry, substantial evidence points to a time when the planet was partially covered with water. Scientists speculate that life could have developed on Mars when it was wetter, and it is possible that life might still exist today in underground aquifers. On Earth, water signifies life, explained Alberto Ferren, an astrobiologist from the Center of Astrobiology in Spain and Cornell University in Ithaca, New York. Although Mars is extremely dry now, numerous indications suggest a much wetter past. The presence of past water could be key in discovering extinct Martian life, and if some water persists today, the chances of finding current life increase significantly. The presence of water on Mars also has broader implications for NASA's research beyond astrobiology. Even if Mars is no longer home to life, or never was, water could be crucial for future human colonies on the planet. It can be used for drinking, shielding against radiation, and as fuel when split into hydrogen and oxygen. Consequently, much of NASA's research on Mars focuses on its water resources. Research spanning decades indicates that rivers, lakes, and seas may have covered Mars billions of years ago. For instance, in 2015, atmospheric maps suggested that Mars could have once had enough water to cover up to 1/5 of the planet. Additionally, another 2015 study found that the shape of certain Martian pebbles implies they rolled for miles down ancient rivers, suggesting that Martian waterways were once stable rather than ephemeral. Analysis of Martian rock layers shows that deeper layers likely formed when Mars had abundant fresh water, while the more recent surface layers indicate an arid environment with only briny pools, leading to the desert we see today, according to Ferren. Most of Mars's water is believed to be frozen in its polar ice caps. If this ice were to melt, it could cover the planet in about 100 feet or 30 meters of water, according to Suniti Karunatilake, a planetary scientist at Louisiana State University. This frozen water might not be limited to the poles, but could also be found at mid-latitudes. For example, in 2015, scientists discovered a massive ice slab as large as California and Texas buried beneath the Martian surface between the equator and the North Pole, covered by protective dust layers. Mars also contains water in the form of hydrated minerals with water chemically bound to them. Future missions to Mars could potentially extract this water by heating the hydrated minerals. Various hydrated minerals, including clays, carbonates, sulfates, and chlorides, have been identified on Mars. Clays and carbonates might suggest the presence of significant amounts of water, potentially suitable for biology due to their less acidic and less salty nature, Ferren noted. These minerals often appear in association with impact craters, canyons, and faults, indicating they are ancient and possibly formed underground before being exposed by erosion. In contrast, sulfates and chlorides generally form with less water and are more acidic and salty. Despite this, Earth's extremophiles can thrive in similar conditions. Michael Meyer, an astrobiologist and lead scientist of NASA's Mars exploration program, observed, "The surprising discovery in the past 15 years is that the amount of water on Mars is far greater than previously thought. We see it at the poles and mid-latitudes." Currently, Mars's surface is extremely arid due to its thin atmosphere, which makes it difficult for liquid water to exist. However, dark streaks on Martian slopes suggest that water might occasionally flow down these formations. The best chance of finding substantial water on Mars may lie in subterranean aquifers, Martian meteorites such as NWA 7034, which landed on Earth after being ejected from Mars by cosmic impacts, hint at the existence of such aquifers in the Martian crust. The most promising location for finding liquid water on Mars is likely the subsurface, Meyer stated. Theoretically, Mars could be warm enough underground to keep water liquid, allowing it to flow and collect. Due to Mars's lower surface gravity, about 1/3 of Earth's, its crust is less dense and more porous, which might allow more water to seep underground. It's plausible that there are deep pockets of water in the Martian crust that we haven't yet detected, McEwen suggested. However, these aquifers are likely deep below the surface. Karuna Talake noted that these aquifers may be several miles down, with volcanic outgassing from the Martian mantle possibly replenishing them intermittently. Lava tubes, natural tunnels formed in solidified lava, might also house these subterranean aquifers. For instance, lava tubes near the Arsia Mons volcano on Mars could serve as analogs to Earth's aquifers, potentially providing geothermal heat to keep water liquid. Deep cave systems might similarly harbor aquifers. Valles Marineris, a canyon system on Mars, contains sulfates similar to those found in cave environments on Earth. These caves could have trapped liquid water, creating a stable environment that might have supported life, Karuna Talake said. If such aquifers exist, ground-penetrating radar surveys focusing on ancient water-bearing areas might help locate them. Although our orbiting assets haven't detected any subterranean aquifers, it's possible we're only seeing the upper kilometer or so due to radar limitations, Meyer remarked. Understanding the history of water on Mars could offer valuable insights into Earth's geological processes and the potential for life elsewhere. As Karuna Talake explained, studying Martian water could reveal how geological activity and water cycles are interconnected, with implications for whether life could arise on Mars or if Earth-like life would remain confined to isolated pockets. Mars and Earth were once more similar, Meyer said. By studying Mars, we can test our understanding of Earth's processes and explore questions such as whether life could have started on Mars, what it might have been like, or why it might have failed to develop. Thanks for joining us on this journey through the mysteries of water on Mars. If you enjoyed this video, please click the subscribe button and check out our other videos for more fascinating content. Your support helps us bring you the latest discoveries and insights from the world of science.